Hello everybody, in this video today we will solve two supported beam but with slope. So the beam is not horizontal, we have an angle between the horizontal axis line and between the beam, that will be the alpha angle. Forget this force, for example 15 kN. Okay, the numbers of the unknowns are the same because we have a fixed support point, a hinge with AX and AY unknown force, and on the next point where do you find the roller support, there we have one unknowns, and now the ground and the movement direction is horizontal, so the reaction force will be vertical, so that will be the BY, exactly that was before. Okay, the solution in this case, because we have a slope, first we will write moment to the A point as we did before, and we will find with this the BY. After we will write a moment to a special point to find the AY, and this special point will be this point here, where the BY and the AX are crossing each other. Why is this point? Because with the first equation we will calculate the BY, but maybe good, maybe wrong, we won't know. But if the next equation is the P point, moment around the P point, doesn't matter because the BY is going through on this point, so won't be inside in our equation. And the AX going through in this point too, so the only unknown will be the AY. This is why so good. After we will check the two results with the submission of Fy, and if it's 0, both AY and BY are good. If not, we will find the problem. And the last will be the submission of Fx to find the Ax. Okay, before we write the equations, we will divide everything to x and y component. So let me write here, for example, we will calculate the F1x component. The concentrated force is the F1, the F1y. After we will divide the trapezoid shape to rectangular and triangle shape. So we will calculate, I write here, first we will calculate the area of the rectangular shape, and after we will calculate from there the x and the y component of the rectangular shape. And I write here because that will be shorter, we will calculate the triangle x and the triangle y, because for that I will show you a very short and easy formula how you can calculate this one. Okay, let me move this one a little bit lower. Yes, there is a good place. Okay, and the moment is the last one, but we don't have to divide that. That is just a simple moment. Okay, let's see one by one. When you see a concentrated force, now this is the F1. Every time draw the horizontal axis line, the x-axis line, exactly where the force is. Why? Because in this way you will see the same angle here. Let me use the red. This red alpha is the same as the black alpha. This is the same because between the same lines, the horizontal line and the beam axis line. So we will calculate the alpha, and that angle will be the same. And the angle what we need to divide the F1 is this one, the green one. I will mark this with beta, because the beta angle is between the horizontal, so between the x line and between the force, and this is what we need, because if you want to know the F1x and the y component, you need an angle between the x or between the y axis line, so not the alpha and not the 30 degrees. So the method is now, first you have to calculate the angle of the beam or the slope of the beam. This is 12 over the horizontal line, let me see, it's 11, 17, 20, it's 30. 30 because 12, let me show you the high, and 30 is the length. See this big triangle, the A point, B point, B point, the big triangle. We can calculate from here, we can calculate the alpha angle. In this case, let me see, 12 over 30, and arcus tangent, this is 21.80 degrees. Okay, first we need this one. After, if you check, to find the beta, you need the angle between the force and the beam. That was the 30 degrees. Now you can't see because of the red line, but that is 30 degrees. And if you see, the beta can calculated with the 30 minus alpha angle. So the angle what we need, the beta, let me write here, the beta angle in this case is the 30 degrees minus the alpha. That is 8.2 degree. So with this, we can divide the F1. The F1x will be the 15 kilonewton force multiplied with the cosinus of 8.2. And the F1y will be the F1 times the sinus 8.2. Let me see with numbers. So 15 times 8.2 cosinus is 14.84 and 7 kilonewton. And the direction is right. Okay, and the y component is 15 times 8.2 sinus, and that is 2.139, yes, kilonewton. Direction is down. Okay, that was the concentrated force. So every time you have to calculate the angle of the beam, and you have to know the angle between the force and the beam, and you have to use both of them. Sometimes in this formula it will be a minus, like now, and sometimes it will be positive. Sometimes you have to audit them. It depends where is the angle, where you can see the angle in the original question, the original problem. If you see the Hungarian video, for example, there you will see the angle is on the opposite side, so there we will audit them. Here I show you, in this case, now you have to subtract them. Okay, let's see the distributed force. Okay, the rectangular shape area, in this case, just check the picture, 3 kilonewton over meter is the value, the height of the rectangular, you can imagine this one, but the length, let me show you with green, the length of the rectangular shape is this one, so it's not 6 but longer, because if you imagine here a perpendicular triangle, you have to see the horizontal length is 6 and the angle of this triangle is the same as the angle of the beam, so the alpha angle. So if you want to continue, this time is the 3 times 6 meter over cosinus alpha, because the 6 over cosinus give you the length of the rectangular shape. You can calculate this one. Later you will see it's unnecessary, by the way, but 3 times 6 over the 21.8, I did it wrong, not sinus but cosinus, so 3 times 6 over 21.8 cosinus, yes, 19.386, and the other values going up. Okay, and now I draw here, this will be the beam, this is your force, the angle here is 90 degrees, it's perpendicular for your beam, and we do the same now. So draw the horizontal line, sorry, let me go back, so horizontal line, and the vertical line for the x and y component. And now this is the alpha angle, again the beam, between the beam and the horizontal line. So this is alpha again, because between the same line. So this small angle is the 90 minus alpha angle, and the opposite angle, this one, will be alpha again in this triangle. So you can calculate the x component if you multiply with the area, the 19.386 kilonewton, if you multiply this one with sinus. So with formula, this one multiply with sinus alpha, and this will be the component if you multiply with cosinus alpha, because this is the next side of next to the angle. Okay, let me move this to a different place. Yes. Okay, so you can calculate these two components if you multiply the 19.386 with sinus alpha, but instead of this, just see the formula. What are we doing? Now multiply the 3 with 6 over cosinus to get this one, and after we will multiply with sinus. So if you do this in one step, you have to see this is the 3 times 6 times sinus over cosinus, and the sinus over cosinus is the tangent. So in shorter way, this is 3 times 6 times tangent alpha, because the sinus over cosinus. And the y component, just check this one, here is cosinus, so 3 times 6 over cosinus times cosinus. So the cosinus is disappeared. So this is simple, 3 times 6. So this will be 18 kilonewton. And that will be, I use the original, so 18 times 12 over 30. The 12 over 30, just go back here, as you see, this is the tangent alpha with numbers. You can divide them, of course, if it's a good number for you, or if you just want to use the first 3 or 4 digits, still good. But this is the exact value of the number. So the formula, and this is what we will use for the triangle 2. If you want to know the y component, the vertical component of the distributed force, multiply the good value, the right value, with the horizontal distance, so only with the 6. Here, this is 3 kilonewton over meter, multiply with 6 meter. So just the horizontal. Why? Because the cosinus won't be there at the end. And if you want to know the x component, just use the y component, 18, and multiply with tangent alpha. So in shorter way, if now we check the triangle, y and x component, the triangle value, the high, is 4, because 7 minus 3 is 4, so the high is 4, and we will multiply only with the horizontal. So 4 times 6, it's 24, and over 2, because it's a triangle. So the y component is 12 kilonewton. That's all. And you don't have to calculate any area, you don't have to use sinus or cosinus, just 12. Again, why? Because the high, let me go back, so the high is 4 times 6, only the horizontal. 4 times 6 is 24, and over 2, because it's a triangle, so every time over 2. Don't forget that one. So 12. And the x component is 12 times the tangent. 12 over 30 kilonewton. That's all. X components is this one, and this is wrong because it's a y, and the y is going up. So up and left here too. Okay. Now we divide everything, so we can start the moment equation. Let me see, MA equals 0. So we will add all of the moment around the A point, and the result has to be 0. Okay, let's see one by one. First, every time the x component, and after I will calculate with the y. So the f1x, 14.847. This is the f1x times, we need this distance, let me mark with green, this one. because from the A point, the perpendicular distance is that one. This is an X force, so we need a Y distance. And we will calculate this one from this triangle, from the green triangle again, because we know the horizontal distance is 6 and we know the angle is alpha. So the Y component, the Y distance, is calculated with the horizontal times tangent alpha. The 6 times 12 over 30 give you the vertical distance of this triangle. Okay, let's see the next one. The Y component is 2.139 times, and the distance is just 6. Let's see the rectangular X, and the rectangular X going to left side, so that goes anti-clockwise rotation. Now I have to mark this as minus, so minus 18 times 12 over 30, this is the force, and multiply with the distance, and now the distance is this one in the middle of the rectangular shape, but we need the vertical distance, so that is 6 plus 5 plus 3, so that is 14. Yes, 14 times tangent alpha. 12 over 30. Okay, and now we need the Y component. The Y component is 80 times, and 40 is the distance. 14 is the distance, sorry. Okay, that was the rectangle. Let me see the triangle. Yes, 12 times 12 over 30 is the force. And the distance, if you check the horizontal distance, 6 plus 5 plus 4 until the triangle place. So how many is that? Okay, 11 plus 4 is 15 times tangent, because we need the vertical part. And the Y component is 12, distance is 15. Okay, and we need a positive 8 from the moment. Just 8, don't multiply with anything, it's a moment, concentrated moment, and minus by times 30. From here we can calculate the by. Let's see, 14.847 times 6 times 12 over 30 plus 2.139 times 6 minus 18 times 12 times 14 times 12 over 30 minus 18 times 14 minus 12 times 12 over 30 times 50 times 12 over 30 minus 12 times 15 plus 8. This is a negative number here, so if I move to the other side, that will be positive, but I have to divide back with negative 30, so the results will be negative. Let me see, it's 14.8217 and another 7. The minus meaning again the same as was in the horizontal beam, so I have to turn it, not up, but in this case it's down. I won't check it now because I want to show you with the submission f of y. If it's 0, that means the by good. Okay, at home of course calculate at least 2 times, because maybe I did a mistake now. We will check later. Okay, the next step is the P point, around moment around the P point. So the submission of MP has to be 0. At first sight it looks horrible because the P point is outside of the beam, but don't worry, I will show you a very simple rule for it, and this moment will be very easy. Let's see the force in the same order. So first the F1x, 14.847 is the force, and let's check the distance. This is so interesting. So from the P point or from the A point, the height of this triangle is the same. You have to see it because the A and the P is in the same level. So this distance, what was from the A point for the AX, the same from the P point. So if you have an X force, what is parallel with the X, you have to use the same direction with the same distance. So 6 times 12 over 30, exactly the same as was here in the A. Let's see the Y component. The Y component, the 2.139. From the P point, you have to see the X and the Y component is turning opposite ways. So I have to write minus 2.139 times, and the distance from the P point is 7 plus 6, 13, plus 6, 19, plus 5 is 24. Okay, let's see the rule again. So the Y component, as you see, changed the primark. So here in the MA moment was positive, now I have to write negative. Same force, and the distance is changed, but if you added them, 6 and 24 give you all of the distance. Because of course if you have a point from the A point or from the P point, if you added the two distance, that will be the full distance. Now it's 30 as you see. So if it was 6, now I have to write 24. The last part is, the remaining parts will be written with the rules. So the next one is the X component. So I will copy it. 18 times 12 over 30, minus 18 times 12 over 30 times 14 times 12 over 30. Exactly the same as was before. And I will turn the Y component, so not negative times 18, but positive times 18 times, and the distance is not 14, but the 30 minus 14, so 16. The next one is again an X component, so I will copy it. Minus 12 times 12 over 30 times 15 times 12 over 30. Without thinking, I have to copy it. And the next one is a Y component, was minus 12. So I will write now positive 12 times. And the distance is, okay, it's not 15, just don't forget it, but 30 minus 15. It's happening, now it's again 15, but don't copy it. Every time is the full distance minus the distance what was in the MA. So, but now is the same. Okay, and the moment will be the same, positive 8. And let's see what did we draw for the AY. Now this is positive AY, so positive AY times 30. And now we can calculate the AY2. Let's see, 14.847, yes, times 6 times 12 over 30 minus 2.139 times 24 minus 18 times 12 times 14 times 12 over 30 plus 18 times 16 minus 12 times 12 times 15 times 12 over 30 plus 12 times 15 plus 8. This is a positive number. I have to move to the other side, will be negative, and divide back with positive 30. So the result is negative. No, I take a mistake. Okay, but will be negative. Sorry, I miscalculated. So again, 14.847 times 6 times 12 over 30 minus minus 2.139 times 24. Yes, minus 18 times 12 times 14 times 12 over 900 plus 18 times 16 minus 12 times 12 times 15 times 12 over 900 plus 12 times 15 plus 8. Okay, move to the other side and divide back with 30. Okay, so 13.0392 kilonewton. It's negative, so I have to turn it down. And now we will check. Maybe good, maybe not. Now we will see. Submission of Fy. Okay. Let's see first the positive force. So the rectangular y 18, the triangle y 12. Okay, we have a negative F1y, so minus 2.139. We have negative 14.82177, the by, and negative 13.0392. Okay, let's see. 18 plus 12 minus 2.139 minus 14.82177 and minus 13.0392 is 0. Exactly 0.000 and one more 0.3. So that is enough for us. It's good. So both AY and BY are good. Okay, the last is the summation of fx to find the AX. So we will write everything what is parallel with the x. We have an AX, we have an opposite, where is F1x, so minus 14 point, how many? 847, yes, 847. And we have positive 18 times 12 over 30. This is the rectangular x, and we need the triangle x. So 12 times 12 over 30, and I think that's all. Yes, that's all. So we can calculate the AX from here. Okay, negative 14.847 plus 18 times 12 over 30 plus 12 times 12 over 30. The results here is minus 2.8, but I have to move to the other side, so it's positive 2.847 kilonewton. This is positive, so I keep the original one. Now it's left. We didn't check the AF, of course. If you want, just do it at home. Write moment to anywhere. What is not inside the action line of what is not in the same line, not in the AX action line, and you will see the moment will be 0 or close to 0, because it's a moment equation. Don't forget, hard to check with moment equations because of the distance. Okay, so again, for the F1, for the concentrated force, we used the connection between the two angles, the alpha angle, the beam angle, and the original 30 degrees. So don't divide with only with the alpha or only with the 30. That is different. You have to use both of them. Sometimes you have to subtract, sometimes you have to add them. Every time check. How you can check? Use a horizontal line. Draw the horizontal line and you will see. I think it's better than if you didn't draw the horizontal line. Okay, with the distributed force, you can calculate in easy way the y component. Just multiply the value with the horizontal distance. If it's a triangle, the same value multiply horizontal distance over 2, because it's a triangle. The x component, now it's easy, just multiply the multiply the vertical distance, so the y component with tangent alpha in both cases. Okay, I guess I told everything, so this is the end of this examples, this problem. We solved everything, we calculated everything and checked the results. Okay guys, if you have questions and you are in my class, just ask in the class if you want, or just write any comments and I try to solve and explain in the next video. Thank you, goodbye.